Okay, getting started with proofs. They ask us to prove something pretty fundamental here, that the tangent of an angle equals its sine divided by its cosine, and that's so basic a concept that I actually had trouble figuring out how to prove it for a while, but it's not so bad when you're using the basic identities. The basic identities are on page 617, and they tell us that anytime you have a sine that represents the y-coordinate divided by the radius of your circle, that the cosine of some angle is your x-coordinate over the radius of your circle, and that the tangent of your angle is your y-coordinate divided by your x-coordinate. Using these, we can do this thing very quickly. We have our left side, which is tan theta. We have our right side, which we're hoping to show is the same thing, which is sine theta over cosine theta. The tangent, according to our basic definition, is y over x. And on the right side, if we just use the basic definitions, we get sine is y over r. Cosine underneath is x over r. And now look what happens when we simplify this. This is y over r times the reciprocal of the denominator, so we get r over x. r's cancel out, and there you are. Tangent gives you the same result as doing sine divided by cosine. And of course, because we're dividing by the cosine, if cosine is ever 0, then we'd get division by 0 and this whole thing would be undefined. So it's understood when we're talking about the tangent function that we better not be in one of the two places where cosine equals 0. In other words, we better not be at pi by 2, and we better not be at 3 pi by 2 either. Those are the places where cosine is 0, and when that happens, tangent is undefined.